We can use what we've learned about the properties of radical expressions to help us solve equations. If we have two variables, a and b, that are equal to each other, it's also true that a squared must equal b squared. This is just another way of saying that it's okay to square both sides of an equation, that when you do that, the equation stays balanced and the two sides remain equal to each other. Here's an example. If I have this equation, 2 times the square root of x equals 4, I'd like to find out what values of x make this expression true. So I can square both sides of this expression. And on the right, I'll have 4 squared, that's 16. On the left, I'm going to need to use the properties that we've learned in Chapter 8 and the beginning of Chapter 11. On the left-hand side, remember that when you have an exponent outside of the parentheses and what's inside is just a multiplication problem, you can distribute that exponent to the two things inside the parentheses. So 2 squared times the square root of x squared. When I simplify then, 2 squared is just 4, the square root of x squared is just x, and 4 squared is 16. So I get the equation 4x equals 16. This I can divide both sides by 4 to get x equals 4. Here are the steps to solving an equation that has a radical symbol in it. Step 1 is to get the radical portion all by itself on one side of the equal sign. So if you look at the equation above, the first thing we're going to need to do is to add 8 to both sides. When we do that, we have 2 times the square root of x equals 8. We're going to continue getting the square root sign all by itself, and we're going to divide both sides of this equation by 2. So we get the square root of x equals 4. Now,